Hello everyone, how's it going? My name is Dan the Tutor. This is the third part in a four-part series on conic sections. This is the third one, which is hyperbolas. We'll get parabolas in the last one, don't worry. Hyperbolas, in my opinion, are the most interesting. They look pretty crazy, but don't worry, we're going to be solving them today. So first, let's talk about the equation for a hyperbola. It's going to be x minus h, quantity squared, over a squared, minus y minus k squared divided by b squared, and again that's equal to 1. So very similar to ellipses. Make sure you watch the ellipses video if you haven't already, because so much of it is similar for hyperbolas. Now the one thing I do want to say is that this is for a horizontal hyperbola, and a horizontal hyperbola is one that looks like this. It opens horizontally. We can have a vertical hyperbola, and the way you do that is you literally switch the positions of the y and the x. So in other words, it's y minus k squared over b squared minus x minus h squared over a squared equals 1. So you see we just made the y positive and the x negative. That's all it is. And so then that's the vertical hyperbola, and what that's going to look like is the exact opposite. It opens upwards and downwards. Now one thing I do want to mention, we still are going to have a focus. We're going to have a focus here and a focus here, and if you remember, the focus is the point where if you were to take, let's pick a random point like here, if you take the distance there to there, that distance is going to be exactly the same as any other distance here that you choose. These distances are equal to each other if you add them up. So in other words, the two green lines equal the two blue lines added up. And that's why the focus is so special. And the equation now for the focus is different than the ellipse. It's going to be f squared equals a squared plus b squared this time, not minus, which is nice. And so now let's look at some problems with hyperbolas. For the first one here, I have x squared minus 9y squared equals 1. Notice the 1 is already in the right position. We need that to be 1. But this b squared is kind of in the wrong spot. We need the b to be in the denominator. So I talk about this in the ellipse video, but whenever that happens, that means b squared equals 1 over 9, which means b is the square root of that, so 1/3. And now for a squared, well, that's just divided by 1. So a squared equals 1, which means a equals 1. Now if you remember for ellipses, right now I would be saying a is greater than b, so it's a horizontal ellipse. However, the same rules do not apply for hyperbolas. Instead, the rule is which one's positive, which one's negative. Looks like x is positive and y is negative. That's why it's a horizontal hyperbola. And so I know it's going to look like this, and the distance is 1 to the left and 1 to the right for my vertices because that's a. I'm going to tell you right now, we're not even going to exactly see how the 1/3 comes into play. I mean, I'll show you in a minute, but first let me draw my hyperbola. Beautiful looking fella right there. Again, the points are 1, 0 and -1, 0. And that's because the center is at 0. And why is it at 0? Because I don't have any h and I don't have any k like we did for ellipses and for circles in this problem. But now if you do want to actually know how that 1/3, the b, comes into play here, I'll show you. Let me zoom in a whole lot. Okay, there we go. And now here's one up and here's one down, which means if I want 1/3, that's about here and about here, okay? And now watch this. I'm going to make a rectangle with my 4 vertices. Watch this. Here's my rectangle. You'll notice I'm drawing it in a dotted line because I'm going to be erasing it later. And now if I want to know what's important about those points, I'm going to have slant asymptotes along the diagonals. What does that mean? Let me show you. I'm going to have a slant asymptote right about there through those 2 diagonals of the rectangle. And then I'm going to have another slant asymptote right there through the other 2 corners. Now you'll notice I didn't draw the best hyperbola because I'm crossing my asymptotes. That's not good. So let me erase my lines and draw it better. So the hyperbola is really going to look like this. Great. So there's my hyperbola. And then the only thing we need to do left is we need to find the focus. So the focus is going to be f squared equals a squared plus b squared this time. So that means f squared equals a, which was 1 squared, plus b, which is 1/3 squared. It's going to be 1 plus 1/9. Common denominator of 9, that's going to be 9/9 plus 1/9. That's 10/9 equals f squared. Then we just take the square root. Our foci are going to be located at plus or minus root 10 over 3. And again, that's because it's centered at 0. Okay, excellent. We're finished with the first hyperbola. Now for the next one, I've got 8y squared minus 18x squared equals 2. So first thing you might notice is that since the y is positive and the x is negative, this is going to be a vertical hyperbola. And then the second thing you should see is that this 2 is not a 1. That needs to be a 1. So I divide everything, and I mean everything, by 2. So 8 divided by 2 is 4, 4y squared, minus 18 divided by 2 is 9, so 9x squared equals 1. There we go. Now we're happy. If you notice, a and b are in the wrong spots. They're both in the numerator instead of the denominator. That means my a squared is going to be 1/4. Actually, that's b, because that's y. Got to be careful there. And then a squared, because it's x, is 1/9. So all I'm saying is that since the 4 and the 9 are in the wrong spot, they are in the denominators for a and b. That means b is 1/2 and a is 1/3. And if I wanted to graph this, I'm going to make my graph really big with my tick marks. So like all the way over here is 1, all the way over here is -1, all the way up here is +1, all the way down here is -1. Because when I put these 4 dots here, b is 1/2, that's the y coordinate, so here and here. And then the x coordinate is 1/3 plus or minus, so that's about here and here. And I draw my rectangle, something like this, and I put in my slant asymptotes like there and about there. Then now I know what the hyperbola is going to look like. So here's one vertice right there on the y, because this is a vertical hyperbola. It's going to go up like that and up like that. And then for the negative side, it's going to be another vertice there, and then going down like that and down like that. So there we go. I've got my hyperbola graphed, and then the only thing I need is the focus, or the foci. So that's going to be f squared equals a squared plus b squared. F squared equals 1/3 squared plus 1/2 squared. It's going to be 1/9 plus 1/4. To get a common denominator, it will be 36. So that's going to be 4 over 4, which gives me 4 over 36 plus 9 over 9 gives me 9 over 36 for the common denominator. That's going to be 13 over 36 equals f squared. Take the square root of everything, plus or minus. So that means the foci are going to be at plus or minus root 13 over square root of 36 is 6. And remember, that's in the y direction because this was a vertical hyperbola. And it was centered at 0 again, so that makes it really easy. And now let's just look at one more. This one I'm going to try and throw you for a loop. I have x squared over 49 equals 1 plus y squared over 16. As you can see, they're both positive this time for x and for y. But that's because the y is on the wrong side. We need y to be on the left. So we subtract y squared over 16 from both sides. And that means you have x squared over 49 minus y squared over 16 equals 1. Now we know a bunch of things already about this hyperbola. First of all, we know it's horizontal because the x is positive and the y is negative. And the second thing we know is, since this is 1 and we're happy with 1 there, we need it to be 1, that means a squared is 49, which means a is 7, and b squared is 16, which means b is 4. So now when I go to draw my hyperbola, 7 tick marks, that's a lot. 1, 2, 3, 4, 5, 6, 7, and then 7 on the left as well. And then 4 tick marks up and down. So here's my x's at -7 and +7, and here's my y's at +4 and -4. Then I have my rectangle I'm going to draw to find the slant asymptotes. Okay, and now I just need to draw a line to connect these shapes. So there's my first one, there's my second one, and again, since I need to draw the hyperbola from my vertices, which are going to be 7 and -7, we're going to start there at the x equals 7 and -7, and there we go. There's my hyperbola looking shape. And then last, of course, our favorite part, the foci. So f squared equals a squared plus b squared, where a is 7, so 7 squared 49, plus b squared 16. Well, b was 4, but b squared's 16. So that means f squared equals, that's going to be 65, and I don't know the square root of 65, nor can I simplify it, so I'm just going to leave it like that. F equals plus or minus root 65, and again, that's in the x direction because it is a horizontal hyperbola. So that's going to do it for this video. Thank you all for watching. In the last video, we're going to be covering parabolas, which are harder than you think, because you think you know a parabola until you see this stuff with conic sections. So stay tuned for that. I'll see you there. Have a good day, and bye-bye.